get this recording going here. Where do you want to start here?
I'll start from number 1.
Okay. Particle moves from A to B in the coordinate plane. Find the increments delta x and delta y in the particle's coordinates. So what's delta x going to be if you move from A to B? And we can draw a graph if it's helpful.
Okay, that works.
A is minus 3 plus 2. That's point A, minus 3 comma 2. And B is minus 1 minus 2. So how do I get from A to B? What do I have to do on the x coordinate? Delta.
What I have to...
That's what they mean by delta x.
Okay.
So you're going from the x coordinate of A to the x coordinate of B.
Would I have to use the distance formula?
No. In other words, they don't even ask you to go in a straight line. They want the change in x. Well, the change in x is from minus 3 to minus 1. So the change in x is a positive 2.
Okay.
What's the change in y?
2 as well.
No, I'm going from a positive 2
4,
to negative 2. And is it plus or minus?
Would it be a minus 4 because it went from A to B?
Correct. Down is negative, up is positive, to the right is positive, to the left is negative. In other words, the reason the delta x was plus 2 was because we had to go to the right 2 units. And this
Okay.
one down 4. Okay? Now, slope is always delta y over delta x. So the slope of that line is minus 2, and that's what they're kind of getting at. Assuming this is leading into calculus. Calculus is all about slope. Okay? So this is really a rather simple question. What delta x is x sub 1 minus x sub 2, and delta y is y sub 1 minus y sub 2. And it would matter if I'm going from B to A as opposed to from A to B. The signs would be opposite on these things. So for number 2, what's delta x?
Delta x, that would be, so it's from A to B. So from negative 3.2 to negative 8.1.
So you want to take
so that would be
x sub 1 minus x sub 2. In other words, it's just slightly different than the slope formula. The slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, since we're going from A to B, we really want to take x sub 1 minus x sub 2. That's our delta x. So it's these in reverse.
Okay.
What's delta x?
Negative 4.9.
Delta x is minus 3.2 minus a negative 8.1. What is that answer?
So delta, wait, are you asking for delta y?
No, delta x, you just gave it to me, but you gave it to me with the wrong sign.
Oh, so it'd be a normal 4.9.
Yeah, the answer to this question here is positive 4.9, right?
Yes.
In other words, if I want x sub 1 minus x sub 2, that's the way I've got to do it. So that's a positive 4.9. And now what's delta y?
0.
Right. Okay. Describe the graphs of the equations in 3 and 4. Well, they jump all over the place here, don't they? What
Mm-hmm.
kind of equation is that in 3?
A circle.
Correct. A circle of radius 1, whose center is at the origin. In other words, that point there is 1, 0. Okay?
Okay.
How about equation number 4? Or
That's a circle as well.
inequality number 4. Correct. It is a circle. The inequality, what's the radius of the circle?
Square root of 3.
Good. And what does the less than or equal to 3 indicate?
Um,
In other words,
it is
that's how this
the
differs from number 3. Number 3 was just the circle, the circumference of the circle.
true.
Means you have to be less than, it's all of this area in here. In other words, you have to be less than the circumference. If
Okay.
that was a greater than or equal, it would be everything outside the circle. Okay?
Okay.
Okay. All right. Point A is minus 1, 2. Point B is minus 2, minus 1. So, plot the points and find the slope. What's the slope of this line here?
I would do y2 minus y1 over x2 minus x1.
Good.
So that would be,
Slope is, let's see, you said y2 minus
yes.
y1 over x sub 2 minus x sub 1. What does that give us? Minus 3 in the numerator and minus 1 in the denominator. So that slope is 3. And it looks like a slope of 3. It's always nice if it looks like what it's supposed to be. Okay. Now, we got to plot both points. Also find the common slope of the lines perpendicular to AB. So before we do number 6, what would the slope of a line perpendicular to AB be?
The opposite reciprocal.
So what would that be?
So that would be negative 1 over 3.
Good. This one is 3. That was negative 1 over 3. And we do the same thing with 6. Okay. These are pretty basic. We may not want to spend all of our time doing these unless you want me.
Okay.
How many of these do you have to do?
Let's skip that one.
Do you have to do all of them?
No, I'm just doing this study for a quiz. I'm just trying to do a little review so I know everything.
You would do 6 exactly the way you did 5, only with these points instead of these 2 points.
Okay.
Okay?
What about number 7?
Yeah, let's go on. What's the equation of the vertical line that goes through this point? It's here. I'll draw the point. The point is right there. Minus 1 comma 4/3. And I'll draw a vertical line that goes through that. What's the equation of that vertical line?
Would it be x equals -1 and y equals 4/3?
No, just x equal -1.
Okay.
Okay. How about the horizontal line that goes through that point? What's the equation of that line?
Y equals 4/3.
You got it. How about number 8, the vertical line?
X equals 0 and y equals -√2.
Okay. All right. These questions 9 through 15 are more typical of algebra questions. So there's two formats for straight lines. One is slope-intercept, which is what? Y equal what?
Slope-intercept. I forgot that formula. Or y equals mx plus b. That's it.
Okay. And the other is point slope. And I feel like you're probably going to need to know both of them. Are you familiar with point slope?
Not really.
Well, here's what point slope is. Notice that it's not much different. If I were to solve the point slope for m, I get y minus y over x minus x. So it's easy enough to memorize. Okay? And you can have an equation of a line that's in either format. There's not one that's more correct than the other. But some are easier to come up with than the other. Question 9 gives us a point and a slope. We want to use the point slope format. If it gives you the y-intercept, like number 11, and slope, then we're going to come up with the slope-intercept method or format, right? So
Yes.
the one you want to come up with is the one that is most suitable to deal with the information you have. Well, in number 9, we have 1 point and we have a slope. So what's it going to end up being?
I'd plug y1.
y1 and plug in your slope for m. So what is it?
So it would be y minus 1 equals -1 parenthesis x minus -1.
And
So then,
that's the answer, actually. You
okay.
don't need to put this into there's nothing magical about slope-intercept format. It's just the first one they teach you, and it's the one that most people generally go to, if they're looking for one. But you'll notice that I was able to plug this point and slope into the point slope format, and in one step I had the answer. Did not take me 2 steps. I could have solved it using the slope-intercept format, but I would have had to solve for b then, which is a lot more work. Okay, let's do 10 using the slope-intercept format. So on number 10, what's the first thing I got to do?
I have to find the slope.
Okay, what's the slope?
So that y2 minus y1 over x2 minus x1, so that would be 5 minus 4 over -2 minus 3.
-1/5. Now we have 2 points and a slope, right?
Yes.
Well, there's still no reason to use the slope-intercept format. In other words, just pick one of the points and use our slope and use the point-slope format. The point-slope format is actually more useful than slope-intercept in an awful lot of cases.
Okay.
So pick the simplest point you can, which is which one?
So I'll do 3 and 4 since there aren't any negatives.
Because exactly. So it's y minus what?
It'll be y minus 4 equals negative 1 over 5, parenthesis x minus 3.
And again, that's the answer. You don't need to modify that further. So again, that was the easiest one to use. Now, for number 11, they give us the slope and the y-intercept. Which one are we going to use now? And what is the answer?
So they give me the slope and the y-intercept. So I would use the slope-intercept.
Okay. So what is the equation going to be?
It'll be 6 equals negative 5 fourths.
Remember, B is the y-intercept.
Yeah, never mind. Y equals negative 5 fourths x plus 6.
There you go. And again, we had just the right information that we could answer it in one step. In other words, every single one of these, I only had to do one step, which is plug it into the right format. How about number 12?
Number 12.
Here's the
So I have my point and my slope.
12 comma minus 9. What's a zero slope mean?
That means it doesn't go up or down.
Line is it?
That means it's a parallel.
It's horizontal.
Okay, horizontal.
A horizontal line has a zero slope. What's a vertical line have, slope-wise?
Undefined.
Right. Horizontal lines are 0, vertical lines are undefined. And undefined basically means infinitely large. That's what undefined means there. A vertical line, you're dividing by 0, so you end up with infinity for your slope. Okay, so we're talking about a horizontal line. Well, what's the equation of a horizontal line that goes through this point?
Would we use point slope?
No? Vertical lines are x equals a number. Horizontal lines are y equals a number.
Okay.
So if it's a horizontal line that has to go through this point, then it's got to be y equal minus 9, right?
Yes.
That's the equation. Y equal
That's it?
9. That's it. That's the answer to that question. There's no x, because that's for all x's. No matter what x is, y equals minus 9. Okay?
Okay.
Now, 13. Little difference. They give you the y-intercept at 4 and the x-intercept at minus 1. So this line looks like this. So first thing we need to figure out is what?
The slope.
It's the slope of that line.
I forgot how to find the slope with just 2. Wait, never mind. You can make your own points.
Right.
So,
eyes over
to the left, it'll be negative 1 and then 0. And the other one will be 0 and 4. So those would be my 2 points.
Okay. Look at that line and tell me what you think the slope is. How far down do I have to go and how far over do I have to go?
4 over negative 1.
Is it positive or negative slope?
Negative.
It's a positive slope.
Oh, it's positive?
Anything that goes from lower left to upper right is positive.
Yeah, that makes sense.
It's got to be a 4.
Okay.
In other words,
I
went down 4 and over 1. So my rise was 4, my run was 1, so it's 4 divided by 1, and the only thing you need to know is whether it's positive or negative. And let me just test you on that, because this is a really important thing, is knowing whether slopes are positive or negative. And it's not always that easy to figure out. So I'm going to draw a bunch of slopes, and you tell me whether I'm drawing a positive or a negative slope. Here's the axis. Positive or negative?
Negative.
Blue line, positive or negative?
Positive.
Green line, positive or negative?
Negative.
All right. So you know those. Whoops. Hold on. Somehow, now I really got it screwed up here. It's not right. We have not fixed this yet. Oh, wow. Let's try this again here. Expand that one to there. And I'm going to have to reopen it. Sorry.
It's all good.
They've changed Windows 10 in the last couple days.
Yeah, I had the update as well.
Yeah, it resembles more of the abilities you used to have when you could size your windows. So let's see. We're on number here. Let me move it over just a hair. Okay. So in 13, we ended up. Oh, we didn't actually. We just ended up coming up with the slope, didn't we? What's the equation of that line? If 13's the slope is 4, what's the equation of the line?
Would I use point slope?
I would use slope-intercept because we have a y-intercept and we just calculated the slope.
Okay, so then it would be y equals 4x plus 4.
Uh-huh. Remember that b is the y-intercept.
Okay.
Okay. So that one, slope-intercept, ended up being the best format to use, not point-slope. We had 2 points and we had a slope, so we could have used point-slope, but it would have been not as neat. In other words, this is very neat. Once you have the slope and an intercept, it's just direct fill in. I guess the other way would have been pretty neat also, but I do have my preferences as to which one to use when I can use both of them. So number 14 passes through this point and it's parallel to this line. So first of all, tell me what the slope of this line is. How do we figure out the slope of that line?
Would it be, okay, so it's 2x plus 5y equals 15.
Put it into y equal mx plus b format.
Okay, so I would move the 2 to the other side.
And I'm going to put it in front because that's getting closer to y equal slope-intercept format. Now y equals minus 2/5 x plus 3. Okay? Now
Okay.
I know a lot about that line. It's slope mainly. Okay? And they want the equation of a line that passes through this point, 5 comma minus 1, and has a slope that's parallel to this, which means the same as that. So give me the equation of that line in one step.
Okay, so the equation for this line
And the only
I
way
could
to do it
do
in one step
slope-intercept.
is to use point slope.
Okay. So y plus 1 equals negative 2 over 5, parenthesis, x minus 5.
Yeah. Now there is another way to do it without using point slope, and that is to solve for b. In other words, plug your point in for x and y. I'm not even sure it's worth telling you. I'm a little afraid that I'm just going to confuse you by giving you, although, you know, in general, I really do believe that you're better off knowing multiple ways to do problems. Just are. So let's do this one time, doing it the other way. Okay?
Mm-hmm.
I'll leave that there because that was the one-step method. But if the question said, give me the answer in slope-intercept format, well, now I know this much. I know y equals minus 2/5 x plus b, right?
Yes.
And I know an x and a y to plug in, and I can solve for b. I'm going to plug in, here's my point, so I'm going to plug in minus 1 for y. I'm going to plug in 5 for x, and that's going to let me solve for b. So b is going to be plus 1. So the equation of this line is y equal minus 2/5 x plus 1. Well, is that the same thing that we got?
I don't think so.
Actually, it is. If you distribute this, you get minus 2/5 x plus 2, and then when you move this 1 over, you get minus 2/5 x plus 1. So
Okay, so that's after you distribute it.
that equation down there is the same as this. This one is in point slope format, and this one's in slope intercept format, but they have to be the same. If they're not the same, we've made a mistake.
Okay.
They're just different formats. But the secret to converting point slope to slope intercept is to distribute that slope to both numbers inside the parentheses, and then to move this number over. And then what you have left is y equal mx plus b format. Okay? But you'll notice that it was a little harder to do it this way because
Yes, for
I had
sure.
to plug in the x and the y and then solve for b, so that was at least one extra step in order to get to that answer. And since they didn't specify what format they wanted it in, always take the most direct route. And the most direct route was point slope format, which gave me my answer in one step merely by plugging in stuff.
Okay.
15. What is the slope of that line? 6x minus 3y equals 5.
So it passes through 5 and negative 1, and is parallel to the line 2x plus 5y equals 15.
No, we're doing number 15, not 14.
Okay, never mind.
We just did 14. So we're on 15. They're giving us this equation, 6x minus 3y equal 5. And they're giving us a different point, but they want a line that's perpendicular to this line that goes through that point. Well, as with all of these problems, the first thing we need to figure out is the slope of this line.
Then we take the reciprocal and opposite.
Yes. And then that'll be the slope of the line that we want to write the equation for. But real quickly, what's the slope of that? You don't even have to solve it for y. You can kind of see what's going to happen. You're going to move the 6x over, right?
Mm-hmm.
And then you're going to divide everything by minus 3. So what's going to be in front of the x when you're done?
2x.
Ah. So the slope of this line is 2. We don't care what the equation of this line is. We just need its slope. So the slope of the perpendicular line, which I write like that, is what?
That would be negative 1 over 2.
Okay. Now we have a point, 4 comma 10. We have a slope. And one step, let's write the equation of that line. Not this one, but the line that goes through this point and has this slope.
Okay, so can I use point slope?
That's the best one. That's the only one that'll give it to you in one step.
Okay, so it would be
Notice it's called point slope, and that's exactly
one
what we
point
have is point and slope.
and slope. So y minus 10 equals negative 1 over 2, parenthesis x minus 4.
All right. Now rewrite that equation in slope-intercept format, just to make sure you can do it.
Okay, so y equals
solve it for y.
I distribute the negative 1/2.
Go ahead.
So then that would be negative 1/2 of x plus 2.
That's equal to y minus 10. So
Then I'll add the 10 to the other side.
all right, so now we have minus 1/2 x plus 12. So if they wanted it in slope-intercept format, it's easy enough to convert. In other words, once you get it in point slope, it's easy to put that in slope-intercept. But if they don't ask for it, don't go out of your way to do extra work to put it in slope-intercept. This is a perfectly fine answer. And in fact, the superior one. They're going to be more impressed if you use point slope than they're going to be if you were to use slope-intercept, because slope-intercept is harder and longer to do. It takes longer to do. All right, let's see here. Got about 20 minutes, so let's go through. All right, 16. Here they want us to find the x and the y-intercepts. Well, there's a particular easy method to use when your equation is in standard format. There's 3 formats. There's slope-intercept, there's point slope, and then there's standard. This is standard, where your x and your y are on one side of the equation and the number is on the other.
Okay.
If I want to know the x and y intercepts, there's one principle that is very, very important, which is the x-intercept comes when y is 0, the y-intercept comes when x is 0. So what's the y-intercept going to be?
4y equals 12.
So there's the y-intercept. What's the x-intercept?
3x equals 12.
So x equal 4.
4.
So that is that line. And notice that I didn't figure out slope. This is one of the few times that you don't have to figure out slope. When they give it to you in standard format and they want just the x and y intercepts, really easy to come up with. But I have no idea what the slope of that line is. I mean, I can see it now that it's down 3 and 4 to the right, so it'd be negative 3/4. But I didn't have to figure out slope in order to answer the question.
Okay.
Yeah, let's do this one just because it looks a little different, a little abnormal looking, but we're going to use exactly the same technique. What's the x-intercept?
It'll be square root of 2x equals root of 6.
Okay, so give me the answer. What's x equal to?
I remember my teacher saying that you could take away the parentheses and make it around the whole equation.
Okay,
And
here's what we have.
yes.
And we're going to divide both sides by square root of 2.
Yes.
Now, what your teacher was saying was that when you have a radical of a divided by a radical of b, that's the same as the radical of 6 divided by 2, which is root.
Radical 3.
So that's the x-intercept.
Okay.
What's the y-intercept?
Y is negative square root of 3y equals square root of 6. So it would be radical negative 2.
Good. Actually, not radical negative 2.
Is it because it's squared rooted?
Here's what we have. We have square root of 6 divided by negative square root of 3, right?
Yes.
So that negative sign is outside the radical. So that's the same thing as negative root 6 over root 3, which is the same thing as negative root 2, which is a lot different than the square root of negative 2. Notice that the square root of negative 2 is an imaginary number. This is not.
Okay.
Okay? All right, let's have a look here. This is an interesting question. We have ax plus by equals c sub 1. And we have another equation that is, I'm going to write it this way. No, can't write it that way. Hold on. Bx minus ay equals a different c. But the a's are the same and the b's are the same. Is there anything special about the relationship between these two lines? Well, I'm guessing that their answer is they're either parallel or perpendicular, right?
Yes.
I mean, what other answer could there be? So let's figure out the slope of the first line. The slope of line 1. And again, remember that when we did this before, we didn't care what this number was. You're going to move the ax over there and divide by b. So what's the slope?
That would be, wait, say that one more time?
Well, solve that for y. And put it into slope-intercept format and then figure out what your n is.
Okay, so if I'm solving for y, so then I would put a 0 for the x, so it would be b.
Oh, no.
Or what?
We're not solving for the y-intercept.
Oh, okay.
This is a different question than 16 and 17. 16 and 17, they wanted just the x and y-intercepts.
Yes.
Problem, they want to know what is funny about these two lines. Well, most certainly what is unique is their slopes. Well, if I have to get the slope of this line, I'm going to move the ax over, and I'm going to have by equals negative ax plus c, right?
Mm-hmm.
So the slope is going to be negative a over b. With me?
Yes.
Now, that's why I didn't care what c was. And that's why they gave it to us as c and not some number. Well, figure out the slope of the other line.
Would that be b over negative a?
Solve that for y.
Would that one be negative b over a?
Again, the C sub 2 makes no difference to me at all. So it's negative B over negative A, which is B over A. Right?
So it's, okay, so it's two negatives and then it makes it a positive afterwards.
Now what's the relationship between these two lines? One of them has a slope of negative A over B and the other one has a slope of B over A.
And positive.
What's the relationship between the two lines?
Perpendicular.
Correct. They're not parallel, they're not the same slopes, but one of the slopes is the negative reciprocal of the other one. And even though we don't know what these numbers are, it doesn't matter. We can see that B over A is the negative reciprocal of minus A over B. All right. Let's see, 19. Where does that particle end up? If it starts at minus 2 comma 3 and its delta x equals 5 and its delta y equals negative 6. Actually, I love it that they're using deltas. I don't find too many students that use it. I like to use it. I always tell students that slope is rise over run, first of all, and rise is delta y and run is delta x. And most of them don't know what I'm talking about because they've been taught that delta y is y sub 2 minus y sub 1 and delta x is x sub 2 minus x sub 1. But this is hammering home the fact that you're talking about a change. Delta x means the change in x. So what's the new point? If I start at minus 2 comma 3 and I change the x by 5 and I change the y by negative 6.
So that means the new point will be negative 3 and 3 and negative 3.
3 for sure, because I'm adding 5 to that.
Yes.
Okay. And negative 3 because I'm subtracting 6 from that. Notice
Correct.
This is going the opposite of the normal direction. In other words, usually when you have 2 points and you want a slope, that's x sub 2, y sub 2, and that's x sub 1, y sub 1. And so they usually say y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is a little different. They give you a starting point, and they merely tell you that delta x is 5. So I've got to go to the right 5, and I've got to go down 6. That's what those two mean. You've got to go right 5 and down 6. Remember, right is positive, left is negative in terms of motion. And up is positive and down is negative in terms of motion.
Okay.
Number 20 is not hard. Let's not spend time doing 20. 20 is pretty simple.
Yes.
Let's look at circles.
Okay, that works.
So what's the general format for the equation of a circle that's not at the origin, whose center is, in other words, here's the equation for a circle whose center is at the origin. Okay? What's the equation of a circle whose center is not at the origin?
Is it like x minus h and a few other things?
Well, that's all it is x minus h plus y minus k. They're still both squared, and it's still equal to r squared. So this is really, if you could only memorize one format, memorize this one. This is the format for a circle. Notice that if I happen to be at the center, then my h and k are 0 and 0, and I end up with x squared plus y squared equals r squared. Okay?
True.
That's what h and k are. H is the x coordinate of the center, k is the y coordinate. All right? So
Okay.
here's they're giving us a radius of A, and the center is at 0, 2. So let's write the equation of that.
Okay, I wrote it down.
What is it?
So it would be 0
X minus 0. We'll plug in
to the
every single
second.
thing.
Okay. And then y minus 2 equals 4.
Correct. And that simplifies to x squared plus, this one you never want to expand that. You always want to leave it in that format because it's useful to have it in the format of a circle.
Okay.
Okay. About 22. It's the equation of that one.
It will be x plus 1 to the second power.
Square. The way you'd verbalize that is you could do it a couple of ways. It's the quantity x plus 1 squared, or you can say left paren x plus 1 right paren squared.
Okay.
Okay?
Then I'll do y.
Always a plus for circles.
Okay.
If
Plus.
that's a minus, then it becomes a hyperbola. Okay? In other words, this same or very similar equation is for ellipses, hyperbolas, and circles. Well, they're just talking about circles for here. But I'll bet you have to cover ellipses and hyperbolas shortly. What's the rest of this equation?
The rest of it is y minus 5 squared equals 10.
All right, cool. And I think that's good enough. Let's go down and do 24. Graph the circles whose equations are given by that. Yeah, 24 is a good one to do. All right. If you can get a circle equation into that format, then it graphs really easy, right? I go to
Yes.
minus 1 comma 5. There's my center. I have a radius of 10, and I draw a circle with a radius of 10. So when you're graphing circles, it's extremely helpful if it starts out in the standard format. Okay?
Okay.
Now, in question 24, that's not the standard format for a circle. But by completing the square, I can make it such. And let's do 24 at least before we leave tonight, because completing the square is a very important part of dealing with circles and ellipses and hyperbolas.
Okay.
First thing I'm going to do is gather my two x's, and I'm going to put a parentheses around them like that. I'm going to leave a little room for completing the square. Next thing, I'm going to gather my y's, and I'm going to leave a little room there. And the final thing is I'm going to take that 4 and move it to the other side, like that. Okay? So,
Okay.
the key thing is I have not changed the equation. That is always the key thing when manipulating equations, is you don't want to change anything. What I have just written is exactly the equation in 24, no different. Okay? Now I'm going to complete the square. Do you remember how to complete the square?
Say that one more time, please.
Do you remember how to complete the square? Take
Not really.
half of that and square it, and then add it.
Half of it and square it.
So I'm going to write a plus 4 right there. Okay, I took half of 4, which is 2, and I squared it. Now, I just changed the equation when I wrote plus 4 there. Well, I got to write plus 4 on this side of the equation to balance it out.
Okay.
Okay? Now let's complete the square in here. Same thing, I take half of that, square it again, plus 4. Again, got to add a 4 over there. Now, the reason I completed the square is because I'm now going to be able to write that as x plus 2 quantity squared plus y minus 2 quantity squared. I add all of these up and I get 4. Now notice I've got it in perfect standard format. How do I graph that? Where do I start? Where's the center? I want to start with the center.
Okay.
Where's the center?
Would it be the radius is 4?
Start with the center. Don't start with the radius.
Okay.
The only important things about a circle are its center and its radius. That covers everything. So let's find its center first. Remember, h and k are the center. Now we're looking at x minus h and y minus k.
So x minus 2.
Minus 2 is the x-coordinate of the center. What's the y-coordinate of the center?
Negative 2.
Okay. No, the other way around. The x-coordinate is minus 2, the y-coordinate is positive 2. So right there is the center of our circle. What's the radius of it?
4.
It'll be tangent to that line there because it's 2 units up with a radius of 2. But that's how you do it. In other words, you take the format they gave you, and by completing the square, the object of completing the square is so that I can write this in this format as a binomial squared, because that's the standard format for a circle. And the same thing with the y's is I'm completing the square so that I can write it as y minus 2 quantity squared. And whenever you complete the square, regardless of what type of problem you're doing it for, you're always going to be able to write it as a monomial term squared. Okay?
Okay.
And you're going to basically have to do the same process for 25 and 26. Is separate all your x's, complete the square, separate all your y's, complete the square, move your number to the other side, go through the completing the square process until it looks like the standard format for a circle.
Okay.
And then you'll be able to graph it. Taylor, I'm going to let you go. You have a good one. I'll talk to you next time.
Thank you. Sounds good. You too. Appreciate it.